What do a tightrope walker, an ice skater, and a yo-yo have in common? RasCas here. I'm going to talk to you about rotational inertia and conservation of angular momentum. So inertia is an object's resistance to acceleration. An object with more inertia requires more force to get it to start moving, and it's more difficult to stop it from moving. An object with more rotational inertia has a greater resistance to a turning motion. So if we have two objects, they have the same mass, but this one is much more difficult to get it to start or stop turning compared to this one. So this has greater rotational inertia. It's the same reason why if I have only a weight on only one end, it's easier to balance it with that weight at the top than it is with that weight at the bottom. It has greater rotational inertia, greater resistance to acceleration. It accelerates more slowly, giving me more time to get my hand underneath it. It's the same reason why it's easier to do this than to do this. More resistance to rotation. Now, momentum is mass by velocity. And so angular momentum is rotational inertia by rotational velocity. Here we have a system where we have a certain amount of angular momentum. If the angular momentum stays the same, but I change the inertia by moving those objects, if I push them further out, the inertia increases and so the velocity decreases as a result. Or if I pull them closer in, the opposite happens, just like our ice skater. So reduce the inertia, increase the velocity.